We think of work as the amount of energy that must be expended to complete a task, such as pushing a large crate across the floor. In physics, if an object is displaced a distance d by a constant force F, then the amount of work done is defined as the product of the force and the distance. If the force is measured in newtons and the distance is measured in meters, then the unit of work is the Newton meter. What is the work done when a box is lifted 2 meters with a force of 200 newtons? Click the Submit button after entering your answer. Using a graph of force versus distance, we see that the work done on the box is equal to the area under the curve for the distance interval it is moved. Now, suppose that a variable force acts on an object as it moves along the x-axis from A to B, as shown in this graph. We can divide the area under the curve into n sub-intervals. The work done on the object can then be approximated by the given Riemann sum. It follows that the work done is equal to the limit of the Riemann sum as the number of sub-intervals approaches infinity. This limit can be evaluated by the definite integral of the force function over the interval from A to B. Consider this force function, which acts on an object over the interval from x equals 2 meters to x equals 4 meters. What is the work done on the object over the given interval? Click the Submit button after selecting your answer. It takes a certain amount of force to stretch a spring beyond its natural or equilibrium length. The relationship between the applied force and the displacement is given by Hooke's law. The proportionality constant K is known as the spring constant. Consider this spring. Use the slider to stretch the spring. The force applied and the displacement of the spring are displayed in the appropriate text boxes. A graph of the force function is also shown. What is the spring constant? Click the Submit button after entering your answer. The slope of the force function curve provides the spring constant. Now, what is the work done stretching the spring 10 centimeters from its equilibrium position? Click the Submit button after selecting your answer. Suppose two objects located along the x-axis attract each other with the given force function. The first object is fixed. The second object is initially located 2 centimeters from the first. A given amount of work is performed on the second object in order to move it along the x-axis away from the first object. How far is the second object from the first after the work is performed? Click the Submit button after selecting your answer. If we lift a box, all parts of the box are displaced vertically by the same amount. Consider this cylindrical water tower. If we fill it with water from a ground level source, not all segments of the water are raised by the same amount. We can think of the filling process as lifting thin, uniformly sized discs of water from the ground level source and stacking them on top of each other in the water tower. The force required to raise a disc of water is that needed to overcome the force of gravity. We know the acceleration due to gravity. The mass of a disc of water is equal to the density of the water times the volume of a disc. The work done on a disc is given by the force times the distance it is raised. The work done filling the tank can be determined by summing the contributions of each of the discs and taking the limit as the number of discs approaches infinity. This limit can be evaluated by the given definite integral. Now, suppose a cylindrical water tower is located 5 meters above the ground and is 5 meters tall. Its radius is 2 meters. What is the amount of work needed to fill the water tower from a hole in the bottom of the tower? Click the Submit button after selecting your answer. Consider this wedge-shaped swimming pool filled with water. A horizontal slice through the pool is rectangular in shape. What is the distance a rectangular slice must be raised to empty it over the top of the pool? Click the Submit button after selecting your answer. In order to empty the pool over the top, each rectangular slice of water must be raised a distance equal to 9 minus y over the interval y equals 0 to y equals 9. How much work is required to pump all of the water over the top of the pool? Click the Submit button after selecting your answer.